Faculty Development Program. Today is the third day of this FDP. On behalf of Institute and on behalf of organizing committee and personally, I welcome all the participants for today's session. And today we have first session will be taken by one of the eminent researcher and the academician and professor, Dr. S.R. Mahadeva Prasanna. He is professor in Indian Institute of Technology, Dharwad. Now I request my fellow colleague, Professor Pushpalata S.A. Madam, to introduce Dr. S.R. Mahadeva Prasanna for all the participants. Sir, on behalf of Institute, Prasanna sir, I welcome you for FDP, sir. Thank you.
Thank you very much, sir.
Thank you, sir. Good morning, everyone. Today I would like to introduce eminent personality, Dr. S.R. Mahadeva Prasanna. Sir has obtained his BE in Electronics and Communication Engineering from SSIT Tumkur in 1994. MTech in Industrial Electronics from NITK Surathkal in 1997 and PhD in Computer Science and Engineering from IIT Madras in 2004. He was faculty member in the Department of Electronics and Electrical Engineering, IIT Guwahati from August 2004 to July 2017. From July 2017 onwards, he is professor in the Department of Electrical Engineering and Dean of Faculty Welfare, Research and Development at IIT Dharwad. He has supervised 19 PhD theses in the speech and handwriting processing area and published about 250 research articles in the national and international journals and conferences. His areas of research interest include speech and handwriting processing. I once again welcome you, sir, on behalf of our institute. Sir will deliver a talk on speech processing using machine learning for health informatics. Thank you, sir.
Thank you,
sir,
madam. Is my slide visible?
Yes, sir. Yes, sir. It's visible.
Okay. Thank you very much. Thank you. Good morning to all of you. I sincerely thank Dr. Mallikarjun Holi sir for giving me this opportunity. So whatever I am today, one of the component who is responsible for this growth is Dr. Holi himself, who helped us and mentored us initially. Thank you, sir, for all that as well. So now, coming to the today's talk, of course, as the FDP title says, it is with reference to artificial intelligence and machine learning applications in biomedical engineering. As all of us being teachers, we are hearing this terminology, both artificial intelligence and machine learning, extensively in the recent past. And everybody, not only for electrical engineering, computer science, instrumentation, biomedical, name it, any field, people are talking about using artificial intelligence and machine learning. So accordingly, biomedical engineering or health-related area is not exception to that. So what I personally believe is just like we are seeing a rapid change in the way of deploying technologies in different areas, but at least we have witnessed it in the speech processing and handwriting processing area. It should be true for health informatics also. Of course, in this today's talk, I will be talking about the latest speech processing technologies that are available, which are essentially giving very good performance. One of the major aspect that can be attributed for this significant improvement in the performance is the development in the field of artificial intelligence and machine learning. Then once such technologies are available, how that can be used in the health informatics fields. That is the focus of my talk, and hence I have titled like that. Of course, since this is going to be an audience from different disciplines, may not be specifically from speech, I will not go deep into the speech, but in as much generic fashion as possible, I would like to send out the message that this artificial intelligence and machine learning seems to be the area which is driving all walks of science and engineering, especially bringing different systems. So accordingly, I request participants to see how some of these ideas can be adopted into their field of teaching and research. Of course, I've organized the talk in the following way. I will briefly introduce about health informatics. Then I'll briefly introduce about speech processing. Then about introduction to the machine learning. Then how the speech processing by machine learning can be used for health informatics. And finally, I summarize my talk. Of course, if you come to the field of health informatics, you can see that it is a basket or a bunch of technologies that are used for processing of data for storage and retrieval of clinical information. So that is what is this health informatics field refers to. So because of the there are many components responsible for that. One is the advent of computers into the medical field, and also many other computing devices, including smart phones and tablets and many other computing devices. Second one is possibility of connecting all these computing devices through the networks, whether it is wired or wireless network. The third one is a significant growth in the computing field that resulted in the computing architectures, which can crunch a lot of data within a fraction of time. And also because of this digitization, this computer smart devices available at the hands of medical personnel, many of the clinical information gets digitized at the different locations. And as a result of that, for any health related task, if you consider, getting amount of digital data for building systems is not a difficult thing what we were thinking in the earlier era, where earlier era, if you want to build a health informatics system, you have to collect the data, go to the doctors or clinics or hospitals, you yourself visit, then you sat there with the doctors and get maybe mostly in the analog form or with their acceptance some digital form, and all because of the process involved in collecting data. We used to spend a lot of time in just data collection, digitization, and processing. By that time, we have already lost 50% of our energy for our enthu to build a health informatics system. Now, that is no more the scenario. In the many digital data, of course, in the health informatics, it is because of the sensitivity of information, may not be directly accessible like other tasks, but at different levels, the digitization has happened. So once you have the digitization, large amount of digital data is available, clinical data. You can indeed build very good systems for deriving some inferences. So this health informatics, one of the goal is, first thing is the digitization of the health records and other clinical information, and also providing remote access of clinical data through the internet, both for accessing by the patients as well as the health professionals. For example, recently I went for a COVID-19 testing. Of course, once the testing is over, in the earlier era, you have to visit the hospital for 2 days or so, then stand in the queue, get your health reports, all those things. Nowadays, it is not required. They just give a website link. You visit that link after this time and enter your credentials. Your report is available directly there. You don't have to visit. You can see the amount of convenience that it is bringing this health informatics field to the next generation. So I don't have to visit once again to the hospital or clinic to see my report. That is the beauty of this health informatics and data available in the form of digital. Of course, we need privacy preservation of the health informatics data. And there are now, since because of a lot of digitization is happening, individuals are also worried about making their data available to the public. But there are researchers working across the globe in terms of privacy preservation of the information. There are, starting from the conventional encryption, decryption, there are many other methods of private anonymization, private preservation methods are there. With the help of that, you anonymize the data and make it available, so that especially in the field of health, unless the data is not made available, it is very difficult to build informatics systems. Fortunately, one level has happened, digitization has happened. Now the next level, it has to happen. If I anonymize or you ensure privacy preservation of the data and make it available to the researchers, both academic and industrial researchers, they will build very good systems which will help the mankind in future. So that is where and in that direction, the significance of artificial intelligence and machine learning comes into picture. We will discuss in detail about what is this artificial intelligence machine learning. One of the underlying requirement in the artificial intelligence machine learning area is the amount of data made available for a specific health informatic task. More the data, better will be the models that are built for drawing the inferences. So in that direction, the current scenario is very ripe, where because of the large amount of digital data available, ensuring privacy preservation, if you make it available to the AI and ML community, they will build health informatics systems that will be very much useful. And coming to the speech processing area, last 1 decade, we have witnessed several speech technologies that have developed, that have shown significant improvement in the performance. All of you might have experienced, even though you may not be working in the speech processing area, many commercially available speech technologies are there. Any of the commercial things, if you see, speech recognition things are there, where you can just speak into them, the message will be recognized. Accordingly, the required action will be performed under your control. Okay, this was not the scenario a decade back. In the last 1 decade, 2012 onwards up to this point, a significant improvement in the performance of speech technologies has taken place. There are 2 things which can be attributed for this. One is, because of this connectivity, just like health informatics, digital data is available, huge amount of speech data is available in the public domain. Name it any spoken language across the world, the speech data can, of course, more prevalently used languages will have more data, whereas the languages that have been spoken by a very small population, you may have a relatively less amount of data, but at least for the major languages, you have good amount of speech data available. So as it is, then you have this good computing architectures based on GPUs, where earlier, which you talk about a computer center holding a large stack of servers, now it is available in a single blade server, this GPU system, which can have the same or even more computing power than what we were visualizing earlier. Third one is the timeliness of this artificial intelligence and machine learning models, specifically machine learning, the deep learning models, have really helped to pull up the performance of the speech technologies. Some of the speech technologies include speech recognition, speech synthesis, speaker recognition, emotion recognition, speech pathology, etc. So many tasks are available. Now, the way I view in this talk proposal is the speech technologies, because of their very good performance, we can indeed use them for helping the health community in the context of health informatics. Essentially, one of the things is making this information access to this clinical data remotely by the patient as well as the health professionals in terms of by exploiting the computing and telecommunication infrastructure. So these things are available once you have the speech technologies. See now, for example, I took the my COVID-19 report, health reports, I have to log into the website and then see the my report. Rather than that, if I have a speech technology using my mobile, I can just call, authenticate myself, and then the system will play out back the report for my this one. So in that way, it will have a very convenient way of accessing the information from the health informatics domain. The beauty of exploiting the speech technologies will be this computing and telecommunication infrastructure is available across the globe at a very reduced cost. We don't have to invest too much into that. Once you have a software representing a given speech technology, we can indeed use that for doing this information access much easier in the case of health informatics domain. If you briefly see the speech processing field, speech is a spoken mode of communication. So if I want to convey some information to all of you, one way is the slides which I have put, where I have described the information in the form of a written text, printed text. Alternatively, I also convey the same information in the spoken mode. That is what the speech mode of communication refers to, the spoken mode of communication. Of course, if you see the basic essence of speech communication or the spoken mode of communication is, we generate some information. I want to convey some information to all of you. That information generation happens in my cognitive system, and then that results in speech signal, and that is the generation of the speech signal. And these speech signals will be transmitted through the communication medium. Then it is received at the recipient reception system, which essentially refers to ears and inner parts. Then they are processed. Of course, once it enters into the inner ear, they get converted into bioechoed potential, goes to the cognitive system, and information comprehension happens. That is how the information flow takes place in the speech processing. See, this is one of all of us use this spoken mode of communication for conveying the information to the others, and also receiving the information from others in the form of in the spoken form, and comprehend the message or information. Incidentally, apart from the information that we are interested in conveying or receiving in a two-party communication or a multi-party communication, the speech also carries other information, like if you want it or not, the person-specific information is there in the speech signal, emotional state of the person is there, the health condition of the person is there, gender information is there, language information is there, many more such characteristics, additional informations are embedded into the speech signal. We exploit implicitly for effectiveness of our communication with the other humans. But in case of general mode of communication, electrical mode of communication, we are putting more emphasis onto the information part. However, if I focus it on to the health informatics part, we can exploit this health condition information that is manifested in the speech signal to also build informatics systems. That is one direction of using the speech processing for in the health informatics field. So if you see that, broadly, if you view how to do that, you extract relevant features representing the health condition from the speech signal. Then the next one is, once you extract the relevant features, you develop models or classifiers using those features. Without exception, you can use the machine learning or the deep learning models for developing the classifiers. For example, if I have some, for example, if I am affected by cold, if all of you can recall this experience, if you're affected by cold, then when you call up your friend and talking over mobile phone, they will say that oh, you seem to be affected by cold. Your cognitive system is so good at identifying that your friend is affected by cold. How that person is not seeing you, you are not sitting in front of her, it is only through the speech signal. Through the speech signal, you are able to make out that this person is affected by cold. This is one common example I am giving. Like this, any of the health conditions, you are going to get embedded into the speech signal characteristics. For example, even so, accordingly, what it gives the clue is if you are able to extract relevant features representing this cold of aspect in the speech signal, then you can develop classifiers for identifying whether the person has a cold or not. Similarly, coming to the emotional conditions. So if somebody is under emotional stress due to any factor happening in his or her life, so at that point, the speech signal, even by listening to the speech signal remotely, you will be able to make out, oh, seems to be you are in a very happy mood, or you are in an angry mood, seem to be in sad mood. Okay, all these things, information are getting conveyed through the speech signal. What it says is the speech signal indeed carries wealth of information other than the message to be conveyed to the other party in the communication. So all these things can be extracted. Relevant features can be extracted representing these aspects. Then using those features, you can build the models for using automated classifiers based on machine learning and deep learning. So that is how there are different ways of exploiting the speech processing field in the health informatics area. So, for example, if you see how speech technologies can be applied into the health informatics area, for want of better terminology, I have broadly classified these speech technologies into two categories. One is already the speech technologies have been developed, not aimed at health informatics. This is for general public use, for general communication and any other task. Of course, you can make use of those technologies in the health informatics field also. Those I am calling it as applied technologies of speech processing. Applied technologies means they were not really meant for the starting point or the basic motivation for developing those technologies are not health informatics. They are having a much wider application area. Of course, you can consider this health informatics also as one area for using them. The other one is the motivation itself is you try to extract the health-related information or health-related information component that is present in the speech signal and extract relevant features representing or emphasizing that health aspect, then build classifiers for modeling such information, then use those built classifiers for later health testing purpose or health informatic task purpose. And those I am calling it as tailor-made approaches. Coming to the applied technologies, for example, speech recognition. Recognition is one of the important technologies in the speech processing area, which essentially represents you speak into a microphone and the microphone is connected to a digital machine, maybe computer, smartphone or anything. It processes that speech signal and gives output the printed text representing the information that is present in the speech signal. That is what is speech recognition. For example, you might have heard medical transcription field. Many things doctors just dictate what is the prescription, description about the health issue, then the corresponding medication and what diets, all those things, when they have to meet again, all this information, they dictate it, record it in the form of speech, and that speech files are transmitted to some other place, medical transcription company somewhere. They sit and listen to it and manually transcribe and send the information back to the doctors for validation and then finally accepted. So now the performance of speech recognition systems are very high. maybe just for health informatics purpose, I can make this overstatement saying that in a specific task, their performance of speech recognition system is comparable to that of human performance. So if that is the case, in place of humans for medical transcription, we can indeed use speech recognition technologies for doing the medical transcription. And this can be directly attributed to the speech recognition models that have been developed by using the developments that have taken place in the field of artificial intelligence and machine learning, specifically the deep learning. Same way, coming to the other important technology, which is most relevant to the health informatics field, will be speech synthesis. Speech synthesis is a much wider application, not only for health informatics. That's where it is coming under that applied technologies area, where just like you generate speech, you can allow computing machine to generate the speech. You type in the text, it plays out the speech. The latest trends using deep learning is such that the speech generated by the computing machines, quality and intelligibility, natural sounding speech. Suppose if you are not shown the computing machine where this speech is getting generated, if it is played remotely to you, it is indistinguishable compared to the human speech. That is the level of proficiency that has been reached in the speech synthesis system. So accordingly, we can use this speech synthesis. Suppose I told I want to know about my results, what happened for my samples that I have given. When I call to that over a phone, first I get the access to the system, then it can just play out the message part. If you don't have a speech synthesis system, somebody has to sit and record those messages for playing. In place of that, we can indeed use speech synthesis technology for generating those speech from the system. Okay, so that is where this applied technologies comes into picture. Coming to the tailor-made technologies, as I briefly explained in the previous slide, the question that we put is, can I extract health-related information from speech? And first question is, can I really extract that health-related information from speech? Suppose I told, when you listen to the speech of your friend or remotely over a mobile phone, you are able to make it whether she has affected by cold or not. That means to say, you are listening to the speech signal and the information about the cold is embedded into the speech signal. Then it is our challenge, both challenge put forward for the latest technologies are available in terms of artificial intelligence machine learning, to take that raw speech signal as input and extract the cold related information from the speech signal. So that is where the first step is, can I extract health related information from speech? Then suppose if I am able to extract, can I indeed model that health related information for specific? For example, how do I recognize that my friend is affected by cold by listening to the speech signal? This is mainly because my cognitive system has got exposure to the speech signals, normal speech signals and speech signals which are learned, produced during the cold condition when the people are affected by cold. Essentially, from production point of view, we have two major cavities which are contributing to the generation of speech. One is the oral cavity, layman term mouth cavity, and another one is the nasal cavity, which is in layman term again is nose, nostrils. So this nasal cavity gets completely blocked or partially blocked depending on the level of the cold you have. Then what happens is most of the speech sounds when they are produced because of the closing of the nasal cavity become nasalized sounds. So can I extract that nasalization information in the speech signal? Based on that, can I use that knowledge for building the model so that at later stage, you give speech signal as input to that system to recognize whether it is a person has a cold or not. If you give a normal speech, it should say it does not seem to be affected by cold, or if it is affected by cold, it should be able to say whether this person has been affected by cold. Next level comes in terms of degree of cold. That is much more challenging terms. This is one example I have taken. Same thing can be for emotional condition. and any other health conditions. Speech production organs have some issues that what we call, if some of the parts in the speech production organs are not functioning properly, to that extent the quality or the speech signal characteristic will deviate from the normal speaker's speech. Accordingly, that information can be extracted from speech and used for finding out what type of production errors this particular person has. So that is how all these tailor-made technologies can be done. Just to summarize, we have the whole field of speech processing. The technologies that are available in the speech processing area can be viewed in applied technologies area and tailor-made technologies area. In the applied technologies area, we have speech technologies that are developed for a wide context, not keep the domain as a view or a window of focus. Then, of course, you can use them into the health informatics. Just I gave speech recognition, speech synthesis as two areas, but of course, many more speaker recognition and other technologies also can be used. These are all applied technologies. Alternatively, when we come to the tailor-made technologies, we are taking from the problem statement starts from the health informatics domain. This is what I'm interested in modeling. So can I extract relevant information from the speech signal that is suitable for this task? If the answer is yes, or it is exploratory, then I can develop tailor-made technologies for that. That is how we can exploit the progress that has happened in the speech processing area for health domain. Now, I used this artificial intelligence, machine learning many times. Of course, if you look into the literature of artificial intelligence, you hear this word, artificial intelligence, pattern recognition, machine learning, deep learning. Maybe some of my esteemed speakers in the sessions already might have told about this, and they are going to tell also in future sessions. It is better to get a clarity in terms of this, what these terminologies mean, and is this the end of the technology arena? Because everybody has created so much hype that everything is taken care by AI and ML, and we don't have to bother about anything. So is that true? For that, we need to get a clarity on these terminologies. Another point is, this terminology like artificial intelligence is not very new. This is there starting from last 4 or 5 decades. Then why does the people talk so much about AI now compared to what happened 4 decades back also? Timing may be wrong, but somewhere maybe 1970s or something people were talking about 4 or 5 decades back. Okay, but now again this bigger wave of artificial intelligence has come. Then people are telling in biomedical engineering field also we can exploit this artificial intelligence and machine learning. So what is that? We need to get a clarity onto that. For example, if you look into the computing field, computer science and engineering, this artificial intelligence refers to the field which focuses on the approaches that enable computers to perform intelligent tasks. I will clarify that what do you mean by intelligent task in the next slide. Essentially, all those studies or approaches that have been put forward, grouped in the computer science field to perform intelligent tasks, they are coming under this bigger umbrella of artificial intelligence. Of course, I will first mention about what is intelligence, why it is called artificial intelligence. So that is how this, of course, then the question comes, I write a computer program to crunch some million numbers. Is it not an intelligent task? Because I have used my cognitive system to write that program. Let us answer that question in the next slide. Then the second one is, one of the subfield in that artificial intelligence, simultaneously along with the development of artificial intelligence, this field of pattern recognition came. So this pattern recognition essentially Again, if you take artificial intelligence as well as pattern recognition, it is motivated from the human way of processing information from the external world. So if you come to the pattern recognition field, it focuses on recognizing the patterns that are present in the given data. And again, the question is, what do you mean by pattern? That also we will see in the later term. Then after this pattern recognition for about 2 decades in early 2000, this buzzword of machine learning came into the computer science field. So there is a relation between pattern recognition and machine learning, but of late people, now that pattern recognition terminology has gone to the back burner, people talk more about the machine learning. If you go to this terminology called machine learning, this again describes those approaches that learn the underlying patterns in a given set of features without being explicitly programmed. So this is a very strong statement, but that is how the hype can be created for machine learning. That is, you learn given set of features or data. You want to learn the pattern that is present in those set of features without telling, oh, the pattern looks like this. You try to capture that only. Without doing that, okay, this pattern, this data is given to you. You discover yourself what the pattern that may be present in this type of data. It is something like we have one module in machine learning, what is called clustering, where there is no labels available about the number of classes there. You have to discover in an indirect way. And like that in machine learning also, what pattern to look for is not told you explicitly. However, you can capture implicitly the pattern that is present in the given data. That is what is this machine learning about. In that specifically, if you come to the one important subfield in the machine learning, what we have, what is called deep learning, which essentially represent the approaches that are used for learning the underlying patterns, not from the features, but from the raw data without being explicitly programmed. So there is you can note down the subtle difference that is there between machine learning and deep learning. In machine learning, features are given for a given task, but we are not explicitly programmed to tell the computing machine that what patterns to look for. You can discover the underlying patterns by yourself. Alternatively, when I go to the deep learning, it is not the features, even the raw data itself is given as input. For example, if I take speech as an example, speech is processed by a proper speech signal processing method to extract relevant features, then use those relevant features as input for discovering the patterns in case of machine learning. Whereas when I come to the deep learning, you directly feed the raw speech signal, digital speech signal as input to the system, and the system will describe or discover the underlying patterns that may be present in the data. So this also, for example, this I have listed artificial intelligence, pattern recognition, machine learning, deep learning. Even though people use these terminologies together, interchangeably, all these things, it is better to find out the relation among these particular 4 terminologies that we have: artificial intelligence, pattern recognition, and machine learning. Now, going more deeper into that, Pushpalata, can you see somebody has unmuted? If you have any questions, anybody has any questions? Okay, so let me go back. So, Pushpalata, can we see?
Yes, sir, I'm checking that.
Can you see the slide now?
Yes, sir, it's visible, sir.
Okay, thank you. So, coming to the delving slightly more detail apart from the definition to the field of artificial intelligence. If you go and look for the dictionary meaning of intelligence, it refers to experiencing, that is, ability to learn and understand and use it for deciding future course. That is the meaning of the word intelligence. Dictionary meaning of the word intelligence is experiencing. Experiencing means ability to learn and understand and use it for deciding future course. And if you see that, all of us have grown from child, toddler to this matured individuals through this process of experiencing the neighborhood, that is external world, and from that we have learned and understand how that works, and that knowledge we use it for deciding future course of action. Take it for anything, starting from how we produce a speech, how we behave with other human beings, how we deal with external world on a daily basis. All these activities which humans do is an intelligent activity. Okay? So, of course, there is a misnomer. People have brought this intelligence only to one component of human behavior, that is academic performance. If somebody scores very high performance, we say is a very intelligent fellow or felly, and otherwise is a dumbo. Okay, sorry, this intelligence word is not meant for that. Human species have been endowed with this intelligence capability, which is essentially a commonsensical way of dealing with the external world on a daily basis, experiencing and use it for deciding future course of action. I give this example. You can learn driving. First, you can imagine when you go for first day to the driving school to learn driving, how much fearful you were to even to touch the steering and to touch the brake and touch the accelerator, and you are so much worried what will happen. And alternative, once over time you learn and understand the tricks of driving and this one, then you are master on the Indian roads. Everybody do gymnastics on Indian roads. Any city you go, so you do gymnastics, but fortunately we are all expert drivers. Somehow we escape any meeting with any accidents, and that is the intelligent activity. Okay, it is not just academic performance. Thus, if you say, what do you mean by human intelligence? It is just that commonsensical way of learning and understanding the process and using that learned knowledge, that experience, to deal with similar instances that will occur in the future. That is that intelligence act. That is what is called human intelligence. It is nothing to do with more intelligent or less intelligent, which we are by misnomer putting into academic performance. Now, coming to the artificial intelligence terminology, these unique characteristics of humans, that is which we call it as human intelligence. Human intelligence means experiencing, that is ability to learn and understand and use this experience for deciding the future course of action, is that ability to mimic that activity on a computing machine, computing field, is called as artificial intelligence. Why it is called artificial intelligence? That natural intelligent capability that we have been endowed with as human species, that is all done by a cognitive system. Of course, we all witness to that. We experience it on a daily basis, otherwise we cannot survive. We are witness, yes, we deal with that. For example, if I am a driver, I know, yes, how do I drive? I understand. If I am able to produce speech, yes, I can generate speech. If I know that particular language, yes, I can comprehend the message given in that language. So all these things are human intelligence activity. We are all witness to that. But if you ask me, can you describe in an algorithmic way, step-by-step way, how exactly I am doing this activity, what aspect of the cognitive system, in a layman term, human brain, is responsible for this? Even though there are a lot of theories from the neuroscience, but they're all theories or the models put forward. but there is no concrete answer for that. That is where what computing domain field thought was, okay, we don't have to worry since we don't know how exactly cognitive system is doing per se. So we just mimic that activity, the intelligent activity of humans, and that we call it as artificial intelligence. Mimicking the human intelligence approach for dealing with the external world is called as artificial intelligence, enabling machines to do so-called intelligent tasks. There, for example, what are the hallmarks of that intelligent activity means? Discovery, skim through the data given to you, learn the information that is present in that, and also dealing with uncertainties and the new situation. This is one of the hallmark characteristics of our intelligent activity of humans. For example, sorry, I'm not getting another example for driving itself. You have been learned driving on some roads. In first you start with stadium where there are no traffic, then you come to some side roads where less traffic is there, and then finally you reach the main road where a lot of traffic is there. Maybe in one particular city you might have learned, but the same knowledge will be applicable when you go to the new city, Indian new city. There is no difficulty in that. There are uncertainties and new situations coming. That road may be very bad or it may be narrow, all those things, but still you deal with that uncertainty because you have discovered, learned, and as a process of learning, you also got this capability of dealing with uncertainties and new situations. So then, thus, in the computing field, they felt, okay, this is one of the important activities humans do, which the conventional Van Neumann architecture of stored program concept does not involve any of these things. Of course, you can write a program, it crunches the data based on the equation you have written, it processes the data and gives out the result. You give million numbers, you tell it to add or square or subtract, it will do. But there is nothing like discovery there. There is nothing like learning from the data. It do that and it will give you the output result. But there is no discovery or learning or dealing with uncertainty involved. And that is where this artificial intelligence takes a significance or diversion compared to the conventional computing that we do, where stored program concept computing that we do. Of course, if you come to the AI field itself, there are two broad directions. One is the symbolic manipulation, where you have the searching, sorting, and all those directions you have symbolic manipulation. The other one is what is called the connectionist approach for artificial intelligence. So this symbolic manipulation of approach of AI is very prevalent in the computer science domain, whereas this connectionist approach of AI seems to be much wider from a practical application point of view. That is where the current generation of community, starting from any engineering, starting from computer science to metallurgy to any industry person, when they are talking about artificial intelligence, they are talking about this connectionist approach for artificial intelligence, where you can build. Connectionist approach means essentially a glorified version of the neural networks. But there is a significant distinction there I will tell in the later slide. This connectionist approach, deep learning approach of capturing or discovering the underlying patterns from the given data is the form of artificial intelligence people are talking about, which can revolutionize the any field you take it up. Unless specified, it is mainly referring to the connectionist approach for the artificial intelligence. So thus, even though mostly technologies and more discussions about that happens in the computer science field, if you see that in your health informatics area or biomedical engineering area, for doing any task, if you want to mimic how humans are doing that task, and given that data, you want an algorithm to do that, you can view that as an artificial intelligence task. You can port it as an artificial intelligence task in the biomedical engineering field. That's the relevance of artificial intelligence comes into the field of biomedical engineering. Coming to I told pattern recognition means essentially deals with recognizing the patterns. Then naturally the question comes, what do you mean by this pattern? What is the difference between, for example, stored program data concept in the one human architecture? There is a program and there is a data which is supplied to that program to do that. Is the data that we are talking about in the general computing is same as the pattern what we are looking for? And that is where the distinction comes between the pattern recognition field and the conventional computing. And this is also motivated by the way humans deal with the data. Humans deal with the data means, let me put a caution here, humans never deal with the data. Deal with data means just they can sum and subtract, but otherwise anything which is presented to their perceptual systems, whether it is auditory perception, visual perception, any other sensory mechanisms like touch, smell, or taste. This here we look for not in terms of data, we look for what is called pattern. Of course, the easiest way to appreciate the difference between pattern and the data will be, suppose when you look at one of your friend for some time, over time, you will learn some facial features. Your cognitive system makes out some facial features of that person's. Based on that, at any later point of time, even if you see your friend from a distance, you will be able to make out he is that person. Maybe you may be meeting after a decade or 2 decades, but still some features are relevant which you will be able to make out the person. Then alternatively, if you take a digital picture of your friend face and take into the computer for processing, if you look in the computer, it is nothing but a 2-dimensional matrix of data. Okay. If you just open the 2-dimensional matrix and see, it is only 2-dimensional data. You don't see a pattern, facial pattern of a person. Okay. It is only just a set of 2-dimensional numbers. Whereas for humans, if you just project it as a picture on the screen, she can make out, yes, he is that my friend whom I have studied together or we have spent some time together. You can find out, see, for computers, it does not have a visual perception system. It only takes the 2-dimensional data and it processes it further. Whereas for humans, that 2-dimensional matrix has no meaning. On the other hand, the visual impression that is created by the data, which gives me a perception of a friend's face, is the pattern. That is what is the difference between the data and pattern. Then the question comes, so what? What is the big deal? Computers need data, you need pattern, you be it. But suppose if I want to build any computer-based systems, which, for example, just like as humans we recognize faces, humans we recognize the speech of other person, humans we recognize colors of the flowers, humans we recognize different flavors. All these things happens, that is because of the pattern way of processing by the humans. Okay. Alternatively, if I go for a computer, general computing, all of these things for visual perception system, it is a pattern. Whereas when you digitize and give it to the computer, it is just a data. Then suppose if I want to do some of these tasks, what humans do, when I look at the flower, I say this is a rose, this is a jasmine. And also I can smell, through the smell, I can say this is a jasmine flower or not. Or I can say what is the color of that. From the color of the flower, I can say mostly this is this particular flower. Or depending on the dimension or the shape of the flower, I can say what flower it is. All these things are the pattern processing capability of humans. And this have much wider applications compared to the general computing you are doing. General computing, you are just limited with, yes, of course, you want to crunch a billion numbers, you can sum or do whatever mathematical operations and get one number out. But that limitation is just one field of counting numbers and doing accounting. But if you want these computing machines to have a much wider use, that is where this pattern recognition field comes into picture. The pattern recognition mimics the pattern way of processing by humans on a computing machine. So mimic human way of dealing with natural data, for example, speech or any natural written message you are reading out and all those things. All these places we just look for natural data. What we do is our 5 sensory organs we have, you sense the information, and our cognitive system selects the relevant features, and then it creates a model for that particular pattern and use that model for a later comparison. So that is where the pattern recognition comes into picture. Just to so the whole field in the version 1 of the artificial intelligence, when for 4 decades was there, one of those byproducts in the artificial intelligence was this pattern recognition. Ability to demonstrate pattern recognition. It was demonstrated how computers can indeed mimic this activity of pattern way of processing the information. Of course, it was supported significantly by this digital signal processing or signal processing field, statistic and probabilistic model. We heavily dependent on these fields to signal processing for extracting relevant features, statistic or probabilistic model for developing relevant models. And using that knowledge, we mimicked this pattern way of processing the information by the humans. However, the performance of that pattern way of processing by the computing machines was not comparable to that of human performance. Not comparable to that of human performance means it is much inferior compared to the human way of doing. For example, just this example is coming to the top of my mind. When earlier now, because of the digital banking, we may not visit the banks. When this digitization was not there, all of us used to regularly visit the bank to deposit money or withdraw the money. So suppose I take a check leaf and write the amount and put the signature. When I put the signature, the clerk or the cash person who is processing your check, even there is a lot of variations in signatures also. The fact that you wrote standing in front of him and you have seen your face, even though there is a lot of variability in the signature, he will say, okay, process, accepted for further processing, you get the cash. Okay. On the other hand, suppose I put a pattern recognition module for signature verification. It accepts only a minimum amount of deviation. If the signature is beyond certain limits, it will reject the check saying that there is a problem with the signature. I will not be able to process the system. So that way, the signature processing by the humans had much higher capability compared to the signature processing by the computing machines. Of course, one of the limitation was at that point, 3 decades back, limited computing power and limited amount of digital data that was available was one of the reasons for unable to build very robust models for doing the pattern recognition task. What is the success story of pattern recognition was we conceptually mimicked human way of dealing with the natural data. Yes, we can also mimic this pattern way of processing with the natural data or external world, but the performance is still inferior compared to the humans. Now coming to the machine learning field, with, as I told, more and more computers or computing devices entering into all walks of life, starting from grocery shops to high-end automation in the companies or even to surgeries. Okay, the digital data is available at your disposal. I say mountains of digital data are available. You take it for any field. So in the earlier era of pattern recognition, we were hungry for data. Oh, I am unable to get more digital data. But now we are given so much digital data, it is like a huge mountain of digital data is sitting in front of you. You don't know how to process that or how to deal with such a huge heap of digital data. So at that point, you don't have that luxury of time and space to carefully think and look for the data and then see what patterns to discover, what patterns to discover from the given digital data. That is where this earlier approach of pattern recognition, where I have the luxury of manual exploration of what patterns to discover by looking at the domain of the field. For example, in case of speech recognition, we always go back and used to read speech production theory, speech perception theory, and any feature that we are going to extract or any pattern that we want to discover from the speech signal is either motivated from the speech production knowledge theory or speech perception knowledge theory. That was the base on which we are going to do further steps in terms of feature extraction and modeling. But now the digital data from so many varied fields, the extreme field compared to the speech recognition is the digital data that gets generated in chain of shopping malls that are there. Any shopping mall you take now throughout the country, the same shopping chain person will keep several stores across the country. Every minute you get so much digital data. There is no production and perception theory there. But still, there are some trends that occur in the digital data. How do I discover the trends that are happening? These trends are specific patterns. For example, the same chain of shops, if you go to Punjab, the certain commodities that are sold on a daily basis there may be quite different compared to what are sold in Hubli and Dharwad, depending on the preference of the community, local community that's there. Then accordingly, I should have automatically method for automatically discovering the trends that are happening in Hubli, Dharwad. Based on that, I can stock the materials here. Okay, so that is where this machine learning came into picture, where I don't care about the what is the theory behind generation of that digital data. I only worry about, is it possible to automatically find out the relation that exists between a specific trend that is happening and the lot of digital data that are generating in a huge manner. That is where this concept of machine learning came into picture. Again, this learning is a misnomer. I have to disambiguate that, because learning, just like intelligence, learning is also another quality of human cognitive system. Of course, when you come to the computing machine, however powerful it is at the base, it is just a digital electronic circuit. It does not have anything more than that. Okay, so in that way, attributing learning to a computing machine in that literal sense of in that sense of human cognition is a misnomer. However, just mimicking the activity of, for example, you are given a data and you are saying this is the trend I am seeing, then you can sit and correlate when you have a small data and then reason out why the trend is coming. That is that human way of exploration. That is learning part. So that is where from that meaning they are telling, okay, machine also can learn. That is where this field of machine learning came. In this field of machine learning, suppose given input digital data and the corresponding trend, which is the output trend, then you find out the relation between the output trend and the input data. That is that functional relation that happens. And the whole machine learning field is given this input and output data. Input is essentially in the conventional machine learning is features for a given task. The purpose is to learn relation that exists between the input and the output data. And this goal of machine learning, as I told, it is essentially to learn this functional mapping that exists between the input output, and that functional mapping is nothing but your the unknown pattern that may be present in the given raw data, given data. That is what is the machine learning. Just to summarize machine learning, a priori you don't say what pattern to look for. You just discover that pattern by finding out the mapping that exists between the input data and the output labels that are given. Now, just quickly to go to the deep learning part before proceeding, coming back. So, in the machine learning field, already somebody gives you the features for that particular task. You don't have to struggle from the raw data to extract the relevant features and then do the pattern discovery. Somebody has given you features. That means, say, from a black box, raw data goes inside and the features comes. You start from there. X is a feature. X is set of features. Using those set of features and their corresponding labels, find out the pattern information that is there between the X and Y. Coming to the deep learning part. In the deep learning part is further simplified from a human purpose, human handling purpose. You don't have to even pass the raw data through a black box to discover the features and then apply for a machine learning task. You give directly the raw data to the deep learning model. First, it will learn the features and then it discovers the patterns. That is why it is called as deep learning. Means from the raw data, first it discovers the relevant features, then uses that relevant features to further discover the underlying patterns that may be present in the features that are learned from the raw data. And this is essentially, when you come to the deep learning, again, it is a human way of learning. Suppose if you see deep learning networks, it has several layers. Compared to the artificial neural networks we have, it comes under the same family, just like, of course, just for fun, we should not drag it too much. But I will say these artificial neural networks which we studied earlier is like cats, whereas our deep learning is more like a tiger. They belong to the same species, but they are more powerful. Okay. Otherwise, if you see the way they walk, the way they run, the way they sleep, the cats also mimic the same way of tigers. Okay. But the powerfulness of the tiger is much higher than compared to the cat. Same thing that is done by your deep learning models. Structure-wise, if you see, it looks like a neural network, but it has a much more capability in terms of many more layers are there, many more computing nodes are there in each layer. This gives the powerfulness for taking the raw data and first deriving the relevant features in the first few layers and then use that knowledge for further discovering the underlying patterns that are there. What it will do is, for example, if you see how this deep learning can be reasoned out with the human way of learning, when we are learning any new thing, from day one itself, we don't learn all the intricacies of that particular aspect. First, we learn some simple things. Then once we learn that simple thing and we appreciate, using those simple things, I will try to expand my horizon for adding some more complexities, then some more complexities. That is how we expand our horizon of learning. Then it gives me the final hold on to that particular task. So learning from experience, then need not specify everything in the beginning, understand in terms of hierarchy of concepts, then each concept defined in terms of its relation to the simpler concept, learning complicated concept out of simpler ones. For example, at least I have experienced this, and maybe it may be true for some of you also. When we go for learning driving to a driving school, the first day or first few days, the coach will say us how to put the key to and start the machine, and then what is the role of right leg, what is the role of left leg, then when to put your leg onto the brake, when to put your leg onto the accelerator, when to put your left leg onto the clutch. So all these things. Then naturally, as a person who are interested in learning, we feel that why this guy should immediately take us to highway and make us to drive, but he is telling you first pedal it. You first get hold on to your leg movements in terms of brake and accelerator, left leg onto the clutch. Of course, now with automatic driving, these things have been simplified. I'm telling manual thing. Then, but we are very much interested in going onto the highways and hitting onto some wall post and then getting fired. Okay. But on the other hand, once we become expert drivers, then we see that, oh my God, that's a very important component. But as a experienced person, he knows. First, he will give you the simpler concepts. first what is important, you get hold on to that. Okay, once you get hold on to how to hold on to the steering, how to hold leg movements, then he will slowly allow you to, okay, you take like this and take like that. And finally, the last concept comes of how to take your vehicle backside, because this is one thing we learned as a last concept. First day itself, you will not say you go backside. Okay, that is what is this deep learning happens. First few layers will learn some simpler information, that is nothing but the features from the raw data, and then use these features later for modeling this one. Same thing as teachers also we do. Now, when we teach the subject, first we teach simpler concept to the students just to appreciate the field. Then in the later modules, we go on increasing the complexity. Okay, so that is where it is. So if you see the difference between the neural networks of deep learning, of course, the concept of deep learning was first originated in the neural network field. Is even if you see one of the well-known deep neural networks which are there, it is nothing but a feed-forward neural network. That means say the terminology, structure, everything. These neural networks are nothing but the cat versions of the tiger. Okay, they are all there. So and also backpropagation learning is the workhorse algorithm for the feed-forward neural network. Only thing is, if you look into the neural network literature, this backpropagation learning algorithm did not work well for the networks having more than a small number of hidden layers. Typically 1 to 3 layers we used to see the performance of neural networks. When it goes beyond 3 layers, already the performance gets either what we call overfitting to the data, or the performance getting saturated. Okay, that means to say we are unable to, even though more data is not available, we are unable to do anything. And this, from the optimization point of view, we can say occurrence of the local minima in the non-convex objective function of the deep network is the main source of difficulty of it. Why I want to say is the concept of deep learning neural networks or deep learning models were there along with the original first edition of the neural networks. The main people who have been contributed now treated as godfathers of deep learning field, their groups initially proposed all these deep learning models, but they were unable to demonstrate their superior performance at that point of time because of the limitation of the backpropagation learning algorithm. That is where, but the time was ripe. For example, if you see the breakthrough that happened in the deep learning area, in 2006, Professor Jeffrey Hinton's group from University of Toronto demonstrated that a deep belief network could be efficiently trained using a greedy layer-wise pre-training. Okay, this Jeffrey Hinton is, along with the 2 others, treated as one of the godfathers of the deep learning field. So their group presented that, oh, of course, if your backpropagation learning algorithm has a problem in training a deep network, we propose an approach where you don't stack all the layers together in one go and train the system. Do layer-wise training, 1 layer at a time. You train that, and then you stack all of them together and just do the fine-tuning. That is what they demonstrated, and they indeed showed that the weights gets optimized properly, and it gives a much superior performance compared to the conventional neural network training. Of course, as soon as their group published this result, other research groups also mimicked this strategy of layer-wise greedy layer-wise training to not to the deep belief network, but other types of deep neural network models, and they indeed saw the same trend in 2007. Of course, rest is history. After that, people have taken the deep learning approaches into many models and shown this one. Then what happened is this, when I say now connectionist approach for artificial intelligence, it essentially refers to these deep neural networks. These deep neural networks outperform that artificial intelligence systems which are based on other machine learning technologies like Gaussian mixture models, hidden Markov models, first versions of the neural networks. Compared to them, these deep neural networks give much higher performance. Okay, so that is where the whole field, it's like a big wave we came. This artificial intelligence and machine learning, when we say in that machine learning, unless specified, the latest trends are due to the deep learning trends. So this is about the summary about the field of artificial intelligence and machine learning. Now I'll switch back to few minutes to the speech processing. So for example, if you take speech processing field, human versus computing machines. So human cognitive system is good at modeling the information in speech, whereas the computing machine is trying to mimic some of these activities for decades. Okay. Then this computing machine approaches, that is, if I am building a speech recognition system, speaker recognition system, speech synthesis system, these are based on pattern recognition machine learning. Now, the recent trends in the speech processing field, the significant improvement in their performance can be attributed to the deep learning networks that have been used for developing speech technologies. So if you see, okay, what typically, unless specified, what approaches comes under machine learning, what approaches comes under deep learning, we can say deep learning is one direction of machine learning, which is based on this connectionist models having large number of layers. Whereas if you just somebody says only machine learning, excluding the deep learning, this includes clustering, dynamic time warping, Gaussian mixture models, to name a few, hidden Markov models, neural networks, supporter vector machines, all these things which we were using earlier, they all can be grouped under machine learning, excluding the deep connectionist models. Neural networks is also a connectionist model, but the deep connectionist model, that can be treated under deep learning model. Coming to the deep learning approach, to begin with, we have deep feed-forward neural network, we have deep belief networks, we have deep autoencoders, then we have generative adversarial networks, convolution neural networks, time delay neural networks. If you see, just as I am telling, many more on a daily basis, people are proposing many types of deep learning models into the literature for different tasks. Of course, they initially demonstrate in one area like speech processing, then people can take it to the other fields. For example, just to give in the speech processing field, before these deep learning models came, we had one task, what is called acoustic modeling, that is nothing but it is the task of recognizing the basic sounds present in the given speech signal. It has an error rate of 27.3%. Using well-known Gaussian mixture model, a hidden Markov model, gave a phoneme error rate of about 27.3%. Whereas the deep neural networks model, based on filter bank energies, gave about 20%. Nearly about for 3 decades, you don't have to worry too much about 3 decades, but for a long time, the performance of the system was hovering around 27.3 only. Somebody proposes a new model, it may become 27.1. Again, another database, it goes back to 28. It is hovering around that 27.3. Whereas an obsolete improvement of 7% came in the initial models that were demonstrated in 2010 or 11 like that, which is published in 2012. Monophone convolution neural networks gave 20%. This gave the push to the whole speech technology domain, first started in academia, but quickly adopted by the industries, and several practical technologies have been developed. So how this phoneme recognition, which is a basic part of speech recognition system, how this changed the performance of the system? The word error rate of 23% came down to 16% in case of using deep neural networks, based on deep neural networks. So that really gave the push to the speech recognition field. And of course, this is the result 1 decade back. Now, later, a lot of improvements have happened. People are talking about now comparable performance to human systems. So for example, if I take speech recognition, that those 2 numbers are only just to illustrate that how the deep neural network approach has revolutionized the field of speech recognition in terms of building technologies that are useful for practical applications. Now, if I have such a good performing speech recognition system, how I can use it in the healthcare domain? Initially, I started with opening remark with reference to that. Now we see that one application is we can use for medical transcription. Then another application is spoken health records. I can directly create the health records. I don't have to sit and type on a computing machine or somebody write it in hand. Somebody just speaks into the machine and the health record gets created. Of course, telemedicine is one area where essentially through the communication you still talk, gets connected to the other field. But with the spoken communication, we can further take the telemedicine to the next level, where automatic extraction of the information happens. Of course, suppose if you have a pathological case, I can try to recognize the pathological case based on the errors that have been done for specific word recognition. For example, if I am unable to produce due to some problem in the production organs, if I am unable to produce a specific sound or set of sounds, I can put those words in the vocabulary of the speech recognition system, and we ask the pathological person to produce that speech, and the machine can recognize and say, okay, instead of this, he or she has produced this, so accordingly we can make use of the pathological case also. Same way, if you come for the speech synthesis, we can, since we are able to generate the natural sounding speech, we can use in the telemedicine. Also, if we have a problem in generating the speech due to problem of speech production organs, the speech synthesis systems are so efficient, we can afford a low-cost technology for generating the speech for us. So that is the speech synthesis. And then, for example, when I say remotely accessing my health record, so that I can do person authentication. For that, I don't have to log into the computer and type the username and password. I can use my voice as a authentication mode and then get access to the remote health record. So that is how we can do it. As I told, this speech analysis for stress, because nowadays, at least in the young generation, because of the lifestyle changes in the family structure, everything, for even small things, children get, or even adults get affected by what happens in their neighborhood or in a daily basis, and they quickly get out of the balance, which is essentially emotional or stress, externally induced stress. So these things can be really analyzed automatically from the speech signal. Once I log into this system, I can start talking to that system. It can recognize what stress you're undergoing. Maybe it relates to analyzing the mental health condition. So accordingly, it can direct to the concerned expert for further counseling or treatment. Coming to the speech pathology, we can work on developing assessment of several disorders by extracting relevant information. All these things are possible now, we can think of, because of large amount of digital data available, then also for artificial intelligence and machine learning related sets. So just to summarize, we have made significant progress in adding values to the computing machines in terms of making them to handle intelligent tasks. That is, human way of handling the task, that thing we have embedded. Starting from pattern recognition, we have come a long way to the current trend, what is happening called deep learning. So initially we started with signal processing, then statistics, then stochastic modeling, then pattern recognition, final machine learning, and now we are in deep learning. So deep learning has resulted in several speech technologies, which is the cause for widespread practical deployment. So this exploiting these latest speech technologies, which is in turn based on artificial intelligence and machine learning, will add significant value for the health informatics area. See, gone were the days where I try to look for some biomedical literature that happens elsewhere and try to build some hardware module inside the lab and demonstrate, and there is no earth to sky difference between from there to building a health system that can be deployed in the public domain because of the human subject is involved. But this artificial intelligence and machine learning reduces the time period required for pushing from, of course, the hardware devices are important, but that is one component of the whole health informatics area. This health informatics area can significantly benefit by exploiting the latent trends that are available in the artificial intelligence and machine learning. I think with that, I will conclude my talk. Thank you very much for the careful hearing, and I will be very happy to take up questions.
Sir, thank you, sir. Thank you very much, sir. You're providing so much insight into the deep learning and machine learning, sir. Sir, I request the participant to post your questions in the chat box. Sir, one question has come from the participants. How neural network can be used in speech recognition?
So, suppose as I was mentioning in the some of these slides, now nobody uses conventional neural networks for speech recognition because it has been proven beyond doubt, as I shown in that slide of acoustic modeling in 2012, it has come. The performance of acoustic modeling system using the deep neural network is way ahead of conventional artificial neural network. So that is where we don't have to really worry about using neural networks nowadays into the speech recognition area, because at any cost, reach the performance of deep neural networks. Suppose if you mean that this, when you say neural network used in speech recognition, if you mean that deep neural network, that is what is currently being used. In the speech processing field, everything people use deep neural network. Of course, whether that is going to be the end of the story, we have to watch and see. But for that, one good thing about this deep neural networks field, several open source toolkits are available in the public domain. Several publicly available databases are there. So using them, we should be able to do it. So I see one more question. Is there a possibility for smell detection? Yeah, this is a very, very important question, because a lot of research can see that. I think Shivkumar, can you mute the mic? So the area itself, people are doing research, because since I am not from that field, it will be difficult to comment on that. See, first we need to understand how that phenomenon is happening. The sensors are to be developed at the first place. First sensors, for example, for speech, the microphone is developed maybe two centuries back as a device, a transducer which can convert the acoustic pressure variation into speech signals, electrical variations. That way, if you have a sensor which can convert this smell into equivalent electrical variations, then you can start using this artificial machine learning to do that. But that I am not aware of what is the latest trend there. Rule mining along with natural language for encouraging speech of medical practitioners. See, for example, this can we use association rule mining along with natural language processing for recognizing speech of medical practitioner. See, the performance of speech recognition system based on deep neural networks is so good. So good. You don't have to bother about looking into any other this rule mining and NLP, all those things. Of course, you don't want to use deep learning models and you want to have a very low footprint system and limited vocabulary, then you can talk about all this rule association, rule mining, all those things. But I don't think we need to worry about that, because in terms of appreciation, because when you say this rule mining, NLP, all those things, even NLP field is dominated by deep learning nowadays. So it is may not be very, on the other hand, putting more effort into using deep learning models and new versions of the deep learning models for building your system, that may help. Of course, I'm assuming that you have a large amount of speech data available for digital data. So, any other questions?
I think no more questions, sir, now.
Oh.
Okay. Thank you, sir. Thank you for providing a valuable information, sir. Thank you very much, sir.
Thank you very much. Thank you all for attending this talk. Thank you very much. Thank you all. Thank you for this opportunity.
Okay, sir.
All.
Yes. Okay, thank you, sir. Thank you very much. Participant, I request we will have a break and we'll meet at 11:30.